Alright, now guys, based on the two different activities, whatever one that you guys chose to do, what is a central angle? Go ahead, Shay.
It's an angle that will like, oh, where's the vertex is at?
Okay, where's the vertex at?
AB. It's up.
What does O represent?
Vertex.
And within a special relationship to the circle, the center, which one we call a central angle. So all the central angle is an angle whose vertex is at the center, right? Okay, so it's an angle whose vertex is at the center. So Shay, you said an example of this would be angle. How do we name angles? AOB. Now, what is an inscribed angle? What do you think what that is? Connor?
Is an angle on the arc.
Okay, what do you mean by on the arc?
Is on 360 of the. Not the. It's on the outside of the circle.
It's on the outside of the circle. Okay, we'll go with that. It's basically an angle, again, whose vertex is on the circle. So an angle whose vertex is on the circle. Wow, that was really bad. Try that again. On the circle. So, yeah, pretty much like this room. All right, now, who can give me an example of what the inscribed angle is based on this diagram? No? No, not C. C angle. Ooh, interesting, Corbin. I'm going to tell you no, but I'll explain why in a minute. Okay? You're right, but you're wrong. Someone besides these two. Alex. Not CAB. BCA. Yep. Angle BCA. Now, one thing, some of you guys got to this point about what is an inscribed angle, what isn't. Corbin, you said CAO. So CAO. By all technicality, yes, that is an inscribed angle. Normally, when we look at inscribed angles, typically this line right here will continue all the way across the circle. Okay. So, by all technicality, yes, CAO is an inscribed angle.
What about BOA?
BOA is not an inscribed angle because the vertex is at the center. Okay. Now, one thing I also want to mention here, if you have a line that cuts through a circle, basically intersects the circle twice, this will be something we'll see in the next couple of days. We call that a secant. If it intersects the circle exactly once, we call that a tangent. That is not the same thing as the tangent that we talked about in trigonometry. Okay, so we're talking about a tangent to a curve. It means that a line intersects the circle exactly once.
So, does it have to be on the outside?
It does have to be. It can be on the inside because that would be intersecting twice. You can only intersect it once.
But what if it's from the center? Oh, no,
Then that would still be a secant.
Okay.
Now, when we talk about intercepted arc, what do we mean by intercepted arc?
It's intercepted like a football.
What do you mean? Okay, let me ask you. An angle ACB,
It's intercepted by
what arc does it intersect?
AB.
AB. So the intercepted arc is the arc between the two endpoints of the angle. Okay, it's the arc between the two endpoints of the angle. Write that down. Should.
Will you write it down?
Do I have to?
Yes.
Arc between two endpoints of Anglais. Now, there were some basic things that you guys were supposed to learn from going through that PowerPoint. And for you guys to do the Inspire activity, kind of went around, talk to you guys a little bit, watch what you guys were doing. I know you guys picked up on these very quickly. So, ultimately, I want to go to here. What was true? If the inscribed angle, what is the relationship between the inscribed angle and its central angle? You guys should have got that. What is the relationship between the measure of an arc and its inscribed angle?
Oh, it's the same.
No, it's not the same. Not for the inscribed. And look at your notes you just took down.
What was the question?
What's the relationship between the measure of the arc and its inscribed angle?
It's half of it.
Half.
Measure angle is equal to.
Wait, so are all of these going to be compared to the central?
So the inscribed angle is half its arc. So the inscribed angle is half the measure of its arc, which means that since the arc measure is the same as the central angle, then the inscribed angle must be half of the central angle. Next question. That since the central angle and the arc had the same measure, then the inscribed angle is half the central angle. On the next one, if I had two inscribed angles that intercept the same arc, notice that both this angle and this angle intercept the same arc, right here. What did you learn about the measure of those two angles? They are equal. So inscribed angles,
Inscribed or intercepted?
inscribed angles that intercept the same arc are congruent. Alright, now suppose I have my diameter. But I have an inscribed angle that intercepts the diameter. What's the measure of that angle?
It's the same thing as. No, it's the same thing as like whatever the angle coming off the
Okay.
outside circle is the same thing as that.
No, not the same thing. It's half. Right there. It says inscribed angle is half the arc. Okay, now Mackenzie, I'm going to put you on the spot, so I need you to think for me. Yep, really. If this is my center, what is this angle right here? Have a straight line. How many degrees in a straight line? Yes, very good. So what's the measure of this arc? 180, right? But according to this, then we just say that the inscribed angle is half the arc. That's 1/2 of 180. So if your inscribed angle intercepts the diameter, it makes a 90-degree angle. Whoa. And what's kind of neat about that, no matter how close at that point gets to the diameter, it stays 90 degrees.
Can you put that in words?
Yes, if the inscribed angle intercepts the diameter, It's a 90-degree angle.
You mean intercept the
What do you mean
diameter?
Intercept. Intercepts.
So wait, the inscribed diameter.
If the inscribed angle intercepts the diameter,
Diameter.
So the arc's 90 degrees.
no, the arc is 180, the angle is 90.
If this inscribed angle
Intercepts the diameter.
the
That's 92. Alright, last one. Talking about a quadrilateral. So again, if I have a circle, and I just have some random quadrilateral, okay, my opposite angles, A and B, let's say those are opposite angles, what's the relationship between angle A and angle B? Alex?
If you add them up, they equal 180 degrees.
You guys understand that. This is one of those big things to understand. With an inscribed quadrilateral, opposite angles are supplementary. With an inscribed quadrilateral, opposite angles are supplementary.
Okay, can you repeat yourself?
One more time.
Inscribed quadrilateral.
With an inscribed quadrilateral, opposite angles are supplementary.